All right, guys. So the last thing on this review for this chapter, we have a couple systems of equations to solve. Now, this first one, we've got one that's y equals, and then one that's this is called standard form, where x and y are on the same side. So this was an example of where we wanted to use substitution, right? And basically what that means is I'm going to take this y value right here, which is this, and I'm going to plug it in for that y value. And let's see what that top equation becomes. Our top equation then becomes 3x plus 2y. I'm not going to write the y there anymore. That's going to become 4x minus 7 equals negative 3. The reason why I do this is now I have no more y variable, only one variable. It's going to make my life very easy. I'm going to do the distribution, and that's going to be 8x minus 14 equals negative 3. I'm going to combine like terms to get 11x minus 14 equals 3. Add 14 to both sides, and I'll get 11x equals 11. By dividing both sides by 11, I'll get my first answer that x equals 1. That's great that x equals 1, but I want to figure out what y equals 2, so I'm going to plug it back in. I'm going to plug it back into this equation. It just seems like it's going to be a little bit easier. If I'm trying to figure out what y equals, let's go to the y equals equation. So y equals 4 times 1 minus 7. I substitute that x out for a 1 because guess what? I just figured out x equals 1. So I get y equals 4 minus 7. So y equals negative 3. And that's the solution to that one. If you want to double check your answer, you can go to the other equation. Right? If I say x equals negative 1 and y equals negative 3, plug it into this one. If x equals 1, this is 3 times 1 plus 2 times negative 3. Does that equal negative 3? I just substitute the negative 3 into y and the x into 1. So I get 3 minus 6. Does that equal negative 3? Yes, it does. So our answer works. The very last question is this one. It's 4x minus 3y equals 8. And 5x plus 7y equals 10. So this one I want to solve with a strategy called elimination. I want to solve it with elimination because I've got two variables, both on the left side. They're both in what we call standard form. If you're struggling with this stuff, go back to my previous videos and look up videos for elimination and substitution. So basically on this one, I could eliminate, some people may look at here and say, I'm going to try to eliminate the x's. I'm going to try to eliminate the y's in this one. But if you want to eliminate the x's, it doesn't mean you're wrong. So if I want to eliminate the y's, I got to think, when do 3 and 7 meet back up again? I want to find their basically the least common multiples. So if I count by 3's, 3, 6, 9, 12, 15, and 7's, 7, 14, 21. 21 is the next time they meet up. So I'm going to have to multiply the top equation by 7, the bottom equation by 3. That'll make this a negative 21 and this a positive 21. So when I add those two equations together, we should get some nice elimination. Just be super careful. You multiply everything by 7. So the top equation becomes 28x minus 21y equals 56. And my bottom equation, if I multiply everything, becomes 15x plus 21y equals 30. So when I add these two together, I'm going to get 86. My y's are going to be eliminated. That was part of the plan. And then I'm going to get 28 plus 15. I have to resort to the calculator because it's so early. Is 43x. So what I need to do here is I need to divide both sides by 43. And I'm going to get my first solution that x equals 2. Awesome. Obviously I'm not done here. I need to go back to the beginning to solve for what y equals. So if x equals 2, I can go to either equation. I'm just going to choose this bottom equation because I kind of erased the top equation, but it doesn't matter, right? I can choose either one. I'm going to plug the 2 in there for x. So this equation becomes 5 times 2 plus 7y equals 10. So I get 10 plus 7y equals 10. So I'm going to solve this one. Subtract 10 from each side, subtract 10. And I get 7y equals 0. Well, I'm going to divide both sides by 7, and I get my second solution, y equals 0. Now, remember we had no solutions and infinite solutions and all that stuff. That would be, infinite solutions would be if we just came down here and had 0 equals 0. That would be infinite solutions. If I get y equals 0 is just a number, and we can totally work with it, right? So those are the final solutions.